So when you're looking at polynomial functions, they're presenting these two polynomial functions in example 6 in a more factored form. Sometimes they're multiplied all the way through. That's a lot easier to determine what the degree of them are because of the fact that you're going to see the highest power of x, and that's going to be the degree of the polynomial. When it's in factored form, I mean, one thing you can do is multiply all this through to simplify it, carry through x minus 4 times itself, and then multiply it to x plus 5, and then multiply all that by -2 and get that expression. However, since it's only asking for the degree, how many turning points it has, and what the horizontal intercepts are, it's actually a little easier to keep this in factored form, although turning points is always something that you more or less have to look at the graph in order to get a better indication of what's going on, especially for something like a. You have -2 times x minus 4 squared times x plus 5. Now, what is the degree of this function? If you would square the x minus 4 and do the FOILing involved, you would have an x squared term in it. And then if you take that trinomial that you would get after you simplify and multiply x plus 5 to that, you would end up with an x cubed term. So that would be the highest degree of x. That's why the degree of this is 3. Which means once you know the degree of this, that means that you can expect up to 3 intercepts, 3 horizontal intercepts, that is, x-intercepts, if you want to call them that, in the function itself. As you can see, there's only 2 listed here. However, it's important to keep in mind that the degree of the function tells you the maximum number of horizontal intercepts that you can have. It doesn't mean that you have to get that many of them. So I could expect anything from 3 horizontal intercepts down to none. It's very unlikely for an odd degree polynomial function, however. How many turning points it has? Now, technically, anything that's degree 3, you could expect up to 1 less than that degree number for turning points. So from that basic premise, we can have up to 2, but we have to verify with the graph what it looks like. So if you were to graph this and play around with your window, you would see that the graph would look like this. Notice that the end behavior, which is something else that you should be keeping tabs of, odd degree polynomial should be pointing in opposite directions. So this starts pointing up, ends pointing down. This is likely the number of turning points that we have, that we can see here, 1, 2 of them, which is in line. I mean, I see 2 turning points. It is degree 3. I don't expect any more turning points. So this one does have 2 because I can see it went from decreasing to increasing, and then it went to decreasing again. So those are your turning points. As far as the horizontal intercepts go, you can see them on the graph, but the horizontal intercepts are going to be any x values that make the y equal 0. Well, by the zero product property, if x minus 4 were to equal 0, this would become 0, and x equaling 4 would make that happen. Notice here's where x is 4, you can see that it is a 0. Also, if x were to be -5, it would make this one 0, which would make the whole thing 0 as well, and you can see the -5 is here. So your 2 horizontal intercepts in ascending order of x coordinates is going to be -5, 0, and 4, 0. For b, you have the quantity of x plus 2 times x minus 7 times 7x plus 8. If you FOIL these two together, you would end up with an x squared term, amongst other ones, in a trinomial. And if you took that result and multiplied the 7x plus 8 through that, you would end up with an x to the 3rd power in that expression as the highest degree as far as x goes. So this would also be a degree 3 polynomial, but we can verify that because from what we learned over here, there's 3 possibilities that it can give me a y value of 0. Well, that means I'm going to have 3 intercepts. You can see there's 3 intercepts down here. That means it's going to be degree 3. However, as we look at the turning points, again, a graph is going to be helpful for that. I do expect up to 2, and I can see I have 2 of them. I can see the 3 intercepts. I do have 2 turning points. That means I'm not going to turn around anywhere else. It is starting pointing down, ending pointing up, so it's pointing in opposite directions again for the end behavior. So that's it, 2 turning points. As far as the horizontal intercepts, again, if x were to be -2, this would be 0. If x were to be 7, this would be 0. And if x were to be a -8/7, this would be 0. And all you're doing is setting these equal to 0 and solving for that. Not showing that here, but basically that's how you would do it. You would set each one of these to 0, solve that equation. So, -2, -8/7, and 7 are the zeros, or where it's intersecting the x-axis. Those are the x-coordinates. Of course, the y-coordinates would be 0. So in ascending order, I'm going to have -2, 0, -8/7, 0, and 7, 0 as those. And so your final solutions for these are, that's what you see here. Moving on to the next problem. Along the same lines, here's graph A. You can see I have 3 x-intercepts, 2 turning points. That means minimum, this has to be a degree 3. It could be higher, because, I mean, there could be other roots that aren't real. So anything involving I and things like that aren't going to show up here. So the degree of the polynomial has to be at least 3. The leading coefficient, since it starts from the lower end and goes to the higher end, and this is an odd degree polynomial, that means that that would indicate a positive leading coefficient. So this is going to be at least 3 and have a positive leading coefficient. This one here, I have 1, 2, 3, 4 horizontal intercepts. I have 3 turning points. That indicates the degree of this polynomial has to at least be 4. It also goes to reason with that because it should be an even degree polynomial, because the polynomial graph has its endpoints pointing in the same direction. It starts off pointing down, it ends pointing down. And that's indication of an even degree polynomial. And because it's pointing down, that means that the leading coefficient is negative. So the degree of this polynomial is at least 4. The leading coefficient would need to be negative on this one. And so that is the end of this problem, and that is the end of this video. If you have any additional questions, please make sure to bring them up during class.